All right, so we are in Precalculus lesson R-9. Today's date is Tuesday, October, that is the wrong color, Tuesday, October 22nd, 2019. Our objective today is Geo. Oh, did you not have your hands up? Sorry, it's going to go to Andrea.
Solve equations with square roots.
It's that easy. And Fiona's going to give her 50 XP for participating if she can find a pencil, which she cannot. You may borrow a pencil from either the Lost and Found or the Cubby if you are still looking, Fiona, and we are waiting for you, Fiona. And then we move on to the simple procedure. Nice. So, our procedure is pretty straightforward. Who wants to read the 1, 2, 3, 4, and 5 for the procedure? Nice and easy. Andrea? No, sorry.
I will.
We'll do Teflon. Andrea already went.
I will.
The Teflon's drinking water.
You were looking at me and you said Andrea. I was like, what?
He does like, what's in
Square both sides to get rid of the root. Get all terms on one side. Factor. Solve using zero product property. Check for extraneous solution.
Yeah, extraneous. Nice. So it's kind of like you would expect. The only thing that most people forget is doing step 5. I'll take it.
Oh, nice!
So Andrea and now Teflon have both gotten their 50 XP. Thank you, Fiona. Yeah, so everything's kind of the same. The only thing that you need to know is check for extraneous solutions, because sometimes you will get weird things that happen. I'll talk about why they... Oh my god.
Nice.
I'll talk about why you get these extraneous solutions in a second. And then the other thing that sometimes we forget is that in order to undo a square root, you need to square. So of course, example 1 and 2 are pretty straightforward, but example 3 and example 4 and 5, they get harder and harder and harder. All right, so example 1. What am I going to do? Quiet raised hand. Quiet raised hand. Quiet raised hand. No one is speaking without a quiet raised hand. James, yes. What are we going to do?
We square both sides to get rid of the root.
There it is. So we're going to take both sides, take it to the power of 2. We're going to square both sides. And James, read me my new equation after I square both sides.
X squared plus 9.
You missed a middle term in there, and we can get some help on there. What about the right-hand side?
X squared.
Ooh, the square and square root should just chunk chunk, and you just are left with
Plus 3.
x plus 3, yeah. All right, thank you, James. I'll take your card. Can someone tell me, close, I don't know where that one, you'll find it later. Can someone tell me what that middle term is on the left-hand side when we do perfect squares? Square the first, double the product, square the last. So take the product, x and negative 3, okay, multiply those, and who shouted that out? I'm taking your HP away. I don't know who it is. Quiet raised hand. What is the middle term, Eva? It is indeed negative 6x. I have a suspicion that it's Teflon, but I'm not sure.
What does it mean?
Okay. All right, so we just squared both sides, so we are on step 1. We're now on to step 2. Who can do the next step? Next step. Step number 2. We're on step number 2. Who can help us? Fiona, go for it. You do indeed. After you do that, tell me what to write. Be careful. If I'm subtracting x, I'm going to do negative 6, minus 7x, and plus 6. There it is. And is equal to 0. All right, so we've gotten all the terms on the same side. I'm not showing my work, and unless you think that you're going to make mistakes, you don't need to show your work from here to here. This is kind of like the Algebra 1 process. And then from here, I'm on to step number 3. Who can do step number 3 for me? You guys got this. I believe in your abilities to factor. You guys can ninja star these in your head? Who's got it? What multiplies to 6? 2 and 3. 2 and 3 don't make 7. 1 and 6. 1 and 6 make 7. What happens? Stego.
X plus 1.
X minus 1. What multiplies to 6? Negative 1 and negative 6. There it is. Again, -1 and -6 add to -7. -1 times -6 multiplies to +6. All right, and then we're on to step number 4. Who can actually find the answer to these guys? Quiet raised hand. Using the zero product property. You guys got this, Fiona? X equals 6 and 1. Perfect. All right, so one of those, I mean, sometimes you will get 2 answers. I won't lie to you. Sometimes you'll get no answers. Sometimes you'll get 1 answer. We need to check to see if any of these are extraneous solutions. So the way that we check those is by plugging them in. This is one of those weird times where in order to get the right answer, you do 100% of the time have to plug them in. It's not like, oh, I'm just checking my work. No, you actually have to check that there's no random extraneous solution. Square roots have that property, and I'll show you why in a sec. So I'm going to come back up here to the original problem, and I'm going to plug them in. So let's plug in 1. I'll do 1 on the left. If I plug in 1, 1 minus 3 should be equal to the square root of 1 plus 3. Well, 1 plus 3 is 4, so the square root of 4 is 2. 1 minus 3 is -2. That doesn't work. 1 is an extraneous solution. This x equal to 1 right here is an extraneous solution because -2 does not equal +2. Let's check 6. Maybe that's an extraneous solution as well, and we have no solutions. Let's check it out. So if I plug in 6, 6 minus 3 should be equal to the square root of 6 plus 3. Well, 6 plus 3 is 9, so the square root of 9 is 3, and 6 minus 3 is 3. 3 does equal 3, so x equals 6 is the only answer that we have. All right, this is the time where I'm going to test your curiosity. How many people are just curious why there's a random extraneous solution? Raise your hand. How many people are curious? I was hoping more people would be curious. Why did we get an answer that didn't work? And this is the answer. So let's look at this problem on Desmos. So if I go to Desmos and I'm doing x minus 3, x plus 3. So let's do x minus 3 and square root of x plus 3. You might say to yourself, well, Mr. Sindel, there's clearly only one solution, and it was at 6, at x equals 6, and that's what we got. How did we get x equals 1 from this thing? And here's the answer. Instead of graphing this thing as square root of x plus 3, I could graph, the technical graph is y squared, because we squared both sides, is equal to x plus 3. And you can see, oh yeah, down here we get an intersection. To be more technical, so we can actually find the intersection, since Desmos is only working if you do square root of x plus 3 and add that minus sign, you can see that, oh yeah, there's where it came from. I have 1 as a solution, but I have a negative y value, and I can't have a negative value when I'm inside of a square root. So anytime that you find a value that makes your y value, or if I plug it in and I get a negative, that will be an answer that doesn't work, just in general for square root problems. So this is the reason. It's because you don't know if you're on the up or bottom, and you're not allowed to be on the bottom. Whenever you square something, we assume that you're on the top. Looks like not very many people care about that, so let's move on to example number 2. All right, walk me through number 2 really quickly. Actually, I think you guys can do number 2. We'll walk through example number 3, but you guys should be able to do 2. We'll do 3 and 4 together, but you right now spend 60 seconds doing example number 2. Go. And actually, before I talk about example number 2, what I want to do is I want to talk about a few of the properties that you need to know. So obviously, if I have something like the square root of x, and I take that to the power of 2, that gets rid of it, and gets rid of the square root rather, and it's going to be just x. But a lot of people are having problems when I square binomials. So as a general rule of thumb, if I have a binomial like a plus b quantity squared, the general formula is that this is equal to a squared plus 2ab plus b squared. And again, that middle term is the one that students forget the most. And if you ever wonder where it comes from, I can demonstrate it to you really, really quickly. If I do a general rectangle, and I say that this length is a plus b, and a plus b. A times a is a squared, a times b is a times b is ab, and b times b is b squared. And you can see if I add up all the area here, I have two of these ab's, an a squared and a b squared, so this is where that formula comes from. And again, I always do the rocking Riley to sleep motion where I square the first, double the product, square the last. It's something that you're going to have memorized. So coming back down here to example number 2, sorry, were people still writing? No? Okay, so coming back down here to example number 2, can someone do the first step for me? Quiet raised hand. Teflon? And what happens when I square both sides? What am I going to have on the left? What am I going to have on the left or right?
On the left, we're gonna have 4x squared
Yep, 4x squared
minus 20x
minus 20x, and that came from multiplying these two, negative 10x, and then doubling it, and then finally plus 25. Perfect. On the right-hand side, I'm going to have 4x minus 2. Perfect. Thank you. Next step. Who's going to do it? Go for it, Fiona.
You add 2, you subtract 4x.
To get what?
4x squared minus plus 27.
All right. And then from here, I'm going to do what, class? I'm going to have to factor it, yeah. So this is an advanced ninja star since this leading coefficient is not 1. So advanced ninja star off here to the side. This advanced ninja star is going to have 4x and 4x in the top left, top right. On the very, very top, I need to now multiply 4 and 27. So that's going to be 4 times 7 is 28, so is this 108? And then on the bottom, I'm going to have negative 24. And then the question is, what are factors of 108? 6 and 18? Yeah, very nice. So negative 6 and negative 18, they both add to negative 24. 6 times 8 is 48. Yeah, so it adds up to, or multiplies to 108. Nice. And then I need to reduce. Quiet raised hand to reduce both sides. Nice and easy fraction reduction. Reduce 4x divided by 6, negative 6, sorry. Fiona again. 2x over negative 3, and you want to do the other side as well? 2x and 9. Perfect. So that means when we factor this thing, we're going to be left with 2x minus 3 and 2x plus 9 is equal to 0. Oh, negative 9. Yep, teacher error. Thank you. 2x minus 9 is equal to 0. Yeah, teacher errors are logging extra credit and the 70 XP. All right, I'm going to pause here because we just did some stuff that we haven't done for a while. Perfect squares, knowing how to multiply those out, knowing how to do advanced ninja star. Are there any questions up to this point? How did I get from here to here? No one has that type of question? I got 108 because I multiplied both the first and last coefficients. So 27 times 4 is 108. Good question, James. Any other questions? All right, so from here I'm going to use the zero product property. The zero product property says that x is going to be equal to what and what. You should be able to do this hopefully in your heads, but if I'm losing you, I can do all the problem out. Fiona did the last two, so I'm going to give it to someone else. Eva, yes. 3 halves, perfect. And 9 halves. And as a decimal, you can say 1.5 or 4.5, but I like fractions. Fractions are nice. All right, now we need to check for extraneous solutions. We need to plug these both back in, see if they actually work. Do you guys already see the one that's not going to work? Which one is going to have some sort of negative? Obviously, the right-hand side can never be negative because I have a square root. square roots domain are always positive. I can't have a square root of a negative 3 unless we are in Precalculus and we are allowed to use complex numbers, but for this whole review unit, and especially for AP Calculus, once we hit that, you will never be dealing with complex numbers, which means everything on the right side should be positive, which means everything on the left side should also be positive. Which of these numbers, maybe both of them, which of these numbers will make this a negative on the left-hand side? You guys see it? One of them makes it positive, one of them makes it negative. If I have the bigger number multiplied by the negative, then I'll have a negative. And we can even test it out, so I'll show you. If I do negative 2 times x, we'll do 3 halves to show you that it does work. 3 halves plus 5. I need someone to simplify this for me. What is negative 2 times 3 halves? Quiet raised hand. Quiet raised hand, where is it? Stego, do you know this? Oh, sorry, I didn't see your hand, Eva, over Geo. Negative 3 and then negative 3 plus 5, Stego, is 2. Perfect. Eva, can you do the next substitution for me since I forgot your hand? I couldn't see your hand. So if I do negative 2, I'm just rewriting the left-hand side up here. Negative 2x plus 5, so negative 2 times 9 halves plus 5. What is negative 2 times 9 halves? And negative 9 plus 5 is negative 4. And I cannot have a negative. I'm not allowed to have a negative on the left-hand side because it's impossible for me to have a negative out of a square root. The square root will always be positive. So this is the extraneous solution. We can write it down. Nine halves is the extraneous solution, so that is not the answer. The only answer is x is equal to 3 halves. All right, give me how you're feeling on a fist of 5. I see James at a 3, Andrea 5, Stego 4, Fiona 5, Eva 4, Teflon 5. Chris, Geo, what are you guys feeling? Geo is at a 3.5, is that right? Or is that a 0? 3.5. And Chris, what are you at? Chris? Hopefully you're above a 3, but if not, I can come talk to you. Let's do example number 3. So example number 3 has a hidden first step, which is getting the square root on one side and all the other terms on the other. So if I squared both sides, I would have a trinomial here, 1, 2, 3 terms squared, which is really gross. That means when I do my multiplication chart, I have to have a 3 by 3 matrix made up here and then multiply them all together. That is really gross, and I don't want to do that. It's too hard. What instead I'm going to do is I'm going to move all these terms, or at least these 2 terms, to the left-hand side, and then square both sides. So can someone subtract 2 and subtract 6x from both sides and tell me what I get? Quiet raised hand. What am I going to do here? James?
You're going to have negative 2x minus 4.
Yeah, definitely minus 5. You said negative 2x or positive 2x?
Positive 2x.
Oh, positive 2x. Okay, positive 2x. And then on the right-hand side, I'm left with, right-hand side, I'm left with,
Square root of 6x plus 3.
there it is, 6x plus 3. So we haven't done anything too tricky. This is still kind of like first half of Algebra 1. Then from here, what am I going to do?
Square both.
Always assume quiet raised hands.
Oh, sorry. I thought you were still talking to me.
Oh, my bad. Someone new now, or maybe someone old. Geo, Chris, I'm worried about you too. Can you tell me what to do from here? Geo, you want to give it a shot? There it is. Can you tell me what happens when I square both sides? Still Geo? Try this one out. Try using this formula up here. 4x squared oh, is it the same? Oh, it's almost the same. Geo 4x squared. So multiply these two together. 2x times negative 5 is negative 10x. Then I have to double that. Negative 20x. And then finally, 25. Nice. And what's on the right-hand side of the equation? There it is, 6x plus 3. Nice. All right, Chris, what am I doing from here?
Squared minus 26x plus 20.
Careful, I'm subtracting 3 from both sides, right?
Oh, sorry, 22. 21. 22, 20.
22 is equal to what on the right-hand side?
0.
0. Very nice, very nice. All right, so here we have a GCF that we might want to factor out before we do an advanced ninja star, otherwise it's going to be kind of too hard on our lives. What is the greatest common factor that I can factor out? Anyone see it? 2. All right, so quiet raised hand. How do I factor out a 2? Teflon? Perfect. So again, we need to do an advanced ninja star on this one. Can someone help me set it up? How do I set up the advanced ninja star on 2x squared minus 13x plus 11? We'll leave that 2 out front. We don't have to worry about him. Advanced ninja star. We'll go with James.
The top will be 22.
So far, so good.
The bottom will be 13. Negative 13.
And then top left, top right.
2x.
2x and 2x, perfect. Who would like to solve this? What times what is 22? Fiona? 11 and 2. And then this reduces to x over negative 1, like that? All right, perfect. So Fiona has this thing factored, so I'm going to write it out for us. The 2 is still left out front, and I'm left with 2x minus 11 and x minus 1, setting that equal to 0. And then from here, I'm going to use the zero product property and actually solve for the 2 different values of x. What are those 2 values of x? Andrea? 11 halves and 2. Nice. So I think that instead of plugging into this original equation, what we should do is plug into this blue equation, 2x minus 5. Sorry, question?
How was that 2?
I don't know how we got 2.
Oh, wait, 1.
Thank you.
No, wait, 2. It is, no, 1.
It's 1, yeah. Thank you, Chris. Can we give Chris the, I don't know how much XP it is for catching an error. I think it's like 20 or 30 or something like that. All right, so let's plug into this blue equation right here. So let's write this out. It's going to be 2, and then x is 11 halves minus 5. And we're just checking the left-hand side because the right-hand side should always be positive. We just need to make sure that the left-hand side is positive. So can anyone simplify this for me? What's 2 times 11 halves? Quiet raised hand, Eva. 11 minus 5 is 6 positive? We're good. All right, so 11 halves is an answer. Check it. What about 1? Let's plug that one in. Again, I'm plugging into the blue equation right here. So it's going to be 2x, so 2 times 1, then minus 5. Someone simplify this for me, please. Quiet raised hand. 2 times 1 minus 5. Teflon? Negative 3. Good or bad? Bad, which means it's, what do we call this thing? This is the extraneous solution, which means the only answer is 11 halves. All right, we're doing good. We have 2 more problems. This one you should now know how to do because it's very similar to example number 3. So I'm going to let you do example 4, and then we'll come back as a class to do example number 5. Good luck on example number 4. All right, so example number 4, quiet raised hand, first step. We're going to go rapid fire mode. First step, Eva.
Add 5 and subtract
And you get 8 plus x is now equal to what? 2x plus 16, and that's being square rooted. All right, next step, quite raised hand. Teflon. Square both sides, so that's going to be squared, that's going to be squared, and I'm left with what? Is equal to? Perfect. Next step, quite raised hand. Fiona.
Minus 16 and minus 2x, which is 64. Wait, x squared plus 14x plus
48 is equal to? Perfect. All right, from here we need to do, you can use advanced ninja star, but you don't need it. It's just a normal ninja star off to the side. So I'm looking for two things to add to 14 and multiply to 48. And those two things are what? Quiet raised hand. Who has this? Fiona, Andrea? 12 and 2. All right, so coming up here, this is going to be 12 and 2. Oh, that doesn't make 48, does it? That's 24. You still get 50. You still get your 50 XP for participating. It's just not quite right. Anyone else? Fiona? 6 and 8. 6 times 8. Ah, that's 48, and that adds up to 14. Perfect. All right, so that's going to be x plus 6 and x plus 8 is equal to 0. And therefore, our x values are what and what? Quiet raised hand. Teflon again.
X minus 6 and then minus 8. Look at all that.
All right. Then we're going to plug into this blue equation up here. When we plug into the blue equation, we had 8 plus x, so negative 6. And that simplifies to just 2, which is positive. So that one's good. All right, let's check the next one. 8 plus negative 8, that's going to be 0. Which, am I allowed to have a square root and get somehow a 0? You are. Look at this. Ready? Square root of 0 is 0. You're allowed to have a square root of 0. So we actually have two different solutions. Yeah, Fiona.
For the 8 plus negative 6, on the other side is this equals, like if you do, like how do you know that you don't have to do the other side?
So I'm looking at this blue equation right here. So I just need to make sure that that equation is positive. They should be the same number, but you can check it if you want. So on the right-hand side, I would have had, if I plug in negative 8, or the negative 6 one. So if I come up here, the negative 6 one, this one is going to be, oh, weird. That didn't work. Yeah, because negative 6, when I plug in negative 6, I'm going to get negative 12. Negative 12 plus 16 is 4. Square root of 4. Oh, yeah, square root of 4 is still 2. 2 equals 2. So you don't actually, I don't think it'll ever not equal to each other. You just need to make sure that it's positive. Yeah, so there are two answers, and you can circle both of them. On Khan Academy, you need to make sure that you enter them in the correct order. They say enter the smallest one first, and I think they mean the most negative one first. So you'd first enter negative 8 and then negative 6 for this type of problem. All right, let's do example 5 together as a class. This one I need square roots on either side of the equation. So I'm going to add this square root of 5 plus or minus 2x onto the right side. So my new equation is, I still have this 3x minus 10 that's being square rooted on the left-hand side. And on the right-hand side, I'm going to have a positive square root of 5 minus 2x. So now that I have a square root on either side of the equal sign, now I can square both sides, and then I can get something nice and easy. So I'm going to square the left, square the right. Someone, quiet raised hand, read out what I'm going to get. Quiet raised hand, who's got it? Fiona? Negative 2x plus 5. That works. We can switch around the order. And then from there, I need to solve. Who can do that for me? need to add and subtract some things to both sides. Teflon? Alright, so if I add 2x on the left-hand side, I'm left with, and on the right-hand side, I'm left with, so if I'm at, are you, I think we should probably add 10 both sides. So if I add 10 to both sides, I get, yeah, 15. Am I making some giant mistake? Oh, yeah, let's actually do it on one side. So -5, it doesn't, I guess we should keep it the same as the other ones. So yeah, we'll have -15 on this side, right? Is equal to 0, and then I need to factor this thing. Quite raised hand, how do I factor 5x minus 15? Greatest common factor is nice and easy. What do we got? Chris, tell us 5 times x. Yep, -3. Next time, just raise your hand. All right, using the zero product property, 5 cannot be 0. You started shouting out the answer. That's why I ended up calling on you. Zero product property, 5 cannot equal 0, so that one doesn't happen. Quite raised hand. X minus 3 equals 0 means that x is equal to, Andrea? X is equal to 3. And let's check that. Make sure that's not the extraneous solution. So when I come back up here, I'm going to say, I'm going to plug it into the blue equation. So 3 is going to make this 9 times, oh, weird things happen here. Check this out. So when I plug in the 3 here, I'm going to get 3 times 3 minus 10. And that's going to be the square root of -1. And I'm not allowed to do that. So that actually is an extraneous solution right here. So this is an extraneous solution, so the answer is no solution. And I feel bad too, because I told Fiona you only need to check one side. I mean, to be very formal, we should be checking both sides. I know just from experience though, as long as one side has variables and numbers and no square root and the other side has a square root, that you technically only need to do one side. But I think we should all get in the habit of checking both sides just to be sure. Yeah, any questions on any of the examples that we did today? Any questions at all? All right, good luck on the homework.